Hey guys, hope you're doing good. So in this video, I'll be giving you some assignment help to proceed with the buckling analysis challenge. I hope by this time you would have tried the buckling analysis on the Cyclone Separator stand and tried to attempt the challenge that you have been provided with. As part of the assignment, you have been asked to create a stiffener between the legs of the Cyclone Separator and do a design study to find the best position to place the stiffener. So now in this video, I'll be helping you model the stiffener in the step file provided to you. So let's look at the model here. So this is the model that you have been provided with, and in this model, we are going to attach a stiffener between the legs of the Cyclone Separator, and we are going to extrude it for some width. So here, as per the challenge, you need to vary the position of the stiffener, and you have been provided with the extrude width of this stiffener. So let's go ahead and open SolidWorks. Here, first open the step file provided to you, and once the model loads in SolidWorks, expand the model list and suppress the Cyclone Separator part. After doing so, click on File and save the model file as a SolidWorks part model with your convenient name. So hit the save button. Now that we have saved the model as a part file, open the part file that we saved just now. And open it. So once you open the file, since we are going to create a stiffener between the legs of the Cyclone Separator, we need to choose a plane to draw the sketch. So here we need to draw the sketch on this plane, and in our case the top plane aligns with the plane that we want to sketch the model. So right click on the top plane and hit the sketch option. Afterwards, then normal to option to view plane in a perpendicular direction. Here choose the rectangle drawing options and click on the corner to corner method to draw a rectangle. Make sure you select the point exactly so that your stiffener is in contact with your legs, else you may end up having a discontinuity between the stiffener and the legs and the Cyclone Separator legs. So we have now drawn the first square. Repeat the same for the inner square and click OK. Here we have created the sketch for the stiffener. Now click on the features and choose extrude. Since we are going to position the stiffener, choose the offset option. Let's say we are offsetting it for 1.5 meters. As you can see, it has gone outside the model. So reverse the direction. For time being, let me choose 1 meter, which is exactly in the center. Now for the width of the stiffener, I'm going to choose 10 mm. Make sure you make a note of the units that we are using. So here we are using meters. So while giving 10 mm, I need to specify it. So I'm going to give 75 mm as the width of the stiffener. Here we have successfully created the stiffener. Hit the OK button and now proceed with the buckling analysis. So to click on the simulation, select new study. From the list choose buckling, name it as per your convenience, click OK. Now for the demo purpose, let's apply the default material and fix the geometry. Zoom in and make sure you are well aware of what you are selecting. In case if you select the wrong face or the edge, we may end up getting the wrong results. So pay attention while selecting the faces to constraint and hit OK. Now let's apply the loads. We are going to apply a load of 150 kN and hit OK. Now let's use the default mesh and run the simulation. So once the simulation is done, you can very well right click on the results. Look at the buckling factor of safety. It is 27, so it's pretty high, and I think we are good with this position of the stiffener, but it may even be higher than this value at any other position of the model. So let's find it out by performing a design study. Click on the new study, choose design study and select design study options. For the list of variables that you need to vary, choose the parameters that you think would affect your design. So here, as part of the challenge, you have been asked to vary the position of the stiffener. So select the dimension and rename it as offset distance and click OK. So we have successfully parameterized the position of the stiffener. So once we have added the parameter, so we need to define the range between which we want to vary the position of the stiffener. Let's say I want to vary it between 0.25 to 1.75 meters, and the change between two variations is 0.25 meter. So after doing it, we need to constrain the design study. So click on add sensor, choose simulation data, and in this case I'm going to limit the buckling factor of safety to a value greater than 25, and this comes from the simulation study that we have named as test 1. Now the ultimate goal of this design optimization is going to be to maximize buckling factor of safety. So here there may be many design studies that would have a value greater than 25, but out of all the simulations that yield a value that greater than 25, I need the maximum value. I need the combination which is going to yield the maximum buckling factor of safety. So let's go ahead and run this optimization. Here you can see in total we have 9 scenarios, and after completing the first scenario, a table will be displayed. So here it is. It has completed the initial study. You can see the position of the stiffener is much high, and I hope by the next iteration it should move down. Yes, so it is moving down. You can see the first simulation yielded a buckling factor of safety value of 12, which is much less than the constraint value 25. So it is colored as red. So the value of buckling factor of safety has increased from 12 to 15. So we have one scenario which has passed our constraint. Okay, now our design study is complete. You can see out of all the scenarios, when the stiffener is placed at an offset distance of 1 meter, it yielded the maximum buckling factor of safety value with a value of 27. So that is our optimum design value. So we have successfully completed a design study on the Cyclone Separator stand. Since we used only one parameter in this case, we had only 7 scenarios. In case you are going to have more parameters to vary, you may end up with more number of iterations for the solver to check. So I hope this video will be helpful for you while attempting the second part of the challenge. Thank you guys for watching, and I'll see you guys in the next video. Bye.